The overall goal of the following experiment is to measure the mechanical properties of the endothelial glycocalyx using an atomic force microscope, or AFM. This is achieved by first culturing a monolayer of endothelial cells under a physiological flow in a bioreactor in order to build up the glycocalyx layer. As a second step, micron-sized beads are attached to AFM cantilevers and used as a probe to measure the resistive force of the cell body and the glycocalyx during indentation. Next, the indentation curves are fit with a two-layer model in order to determine the glycocalyx modulus and thickness. Results are obtained that show that the endothelial glycocalyx has a modulus of 0.7 kilopascals and a thickness of 380 nanometers based on the two-layer analysis.
Hi, I'm Rick Waugh. I'm Chair of Biomedical Engineering at the University of Rochester. There's been a lot of discussion in recent years about the possible role of the endothelial glycocalyx in inflammation, in particular as to whether it might act as a protective barrier to prevent unwanted cell adhesion during inflammation. One of the keys to resolving the questions that surround this issue is the ability to measure the physical properties, namely the thickness and the stiffness of this layer, both in normal conditions and during the inflammatory response.
I'm Marsh. I'm a graduate student at the University of Rochester's Department of Biomedical Engineering. The big trouble in characterizing the endothelial glycocalyx is it's incredibly soft. The approach that we came up with is to affix a large bead to the tip of an AFM cantilever so that the forces measured will be resolvable with the AFM.
To begin this procedure, construct a flow chamber like the one